Okay. So the reason that we have different ways of connecting to the internet, you have your Ethernet jack that you plug into the wall, or you have Wi-Fi, and uh, you can do it via your cell phone. You can do it from back in the 90s, or even before that. You had dial-up. Like you used to have to actually put a handset onto a thing. They do it in the Matrix when they're putting Neo, taking him out of the Matrix. These old your dial-up modems, or you'd have to. That's because the internet protocol is a very abstract protocol. It doesn't say anything about voltages or um, uh, wirings or anything like that. It's actually so abstract you can send IP packets via carrier pigeon. They actually did this about, I'm going to say 10 years ago, because they defined, this is standard, it was written on April Fool's Day, for sending IP packets by carrier pigeon. And it was called the slowest internet connection anybody had ever used. But so, the way that this protocol is defined, the one that we use, at least like in America, because there are two versions right now. The more common one, like the one that I deal with every day, is IPv4, and they defined this in the mid '80s, and in it they defined an IP address as 4 bytes. That's 4 numbers from 0 to 255. And you might have seen an IP address before. Like, for instance, if you connect to your router, you'll go to usually something like 192.168.1.1. And that's, there are certain addresses, certain numbers, certain portions of the address space have been blocked out, saying that they shouldn't go out to the internet. And so numbers that start with 192 are one of them. Also numbers that start with 10 are, addresses that start with 10 are supposed to be for connections from the computer to the computer. Which is, you'll use that like if the computer's providing something that would normally come from the internet. And so an IP address is kind of like a phone number. A phone number, you have your area code, which is 3 digits from wherever you lived in 2005 before we had cell phones. And then you have another 3 digits, and then you have a further 4 digits. And so, because each of these digits can be from 1 to, or 0 to 10, we have, in theory, an address, phone number, a number of phone numbers that is capped at, in America, at 10 billion. 1 0 0 0 0 0 0 0 0 0 loop, loop. Of course, we don't have exactly that many because, like IP addresses, certain area codes aren't valid. Like every area code has to have a 1 or a 0. But that's just a rule, and we can expand that. Like, so, funny thing, you multiply 255 by itself 4 times, 255 to the power of 4. We only have about 4 billion and some IP addresses in IPv4. This is because when they were designing IP, they thought, well, I mean, computers are really, rare and obscure things. It's not like we're ever going to have more computers than phones. Today, of course, we're moving into a world where, like, every computer is a phone and vice versa. But, there aren't enough IP addresses for every person, which is especially a problem now that we have every person has at least one thing connected to the internet, or that's where we're going toward. There are, of course, still places where people don't have internet connections. But so because of that, and when they originally drew up the IP address space, they said like every IP address that starts with 8 is going to go to Apple, and every IP address that starts at 6 is going to go to the Ford Motor Company, and they've since like tried to walk that back so that we have because you couldn't have a 256th of all IP addresses going to one company when the entire world needs these addresses. But so that's still kind of a stopgap fix because we're going to run out. In fact, we have run out a number of times. And we do some trickery that I can go into in probably another video, explaining why how we make it so you can have more than one computer in your house using the same IP address. It sort of just tracks who's using what. But the real solution is IPv6, which is going to have 128 bits of address space, and an IPv6 address looks like a series of hexadecimal numbers. That's numbers that are a digit or a letter from A to F, and then any number of them separated by colons. But we're not using it because we had a bunch of stuff that was written with IPv4, and it's too much of a pain to fix it. So, will we ever be on IPv6? It's not exactly clear. Hopefully. But the world today, and most of the stuff about IPv4, except for the size of the addresses, is true for IPv6. There are some technicalities. If you're like a network engineer, you will learn what's different. But for the average internet coder, all you need to know is how IP works. So you have a packet and you have your target address where you're sending it to, and you have your source address, which is your address where it will send the reply. So because I'm no good at coming up with examples, I've got a random generator for addresses. So let's say that we're sending one to the random generator is a little weird though. Sending one to 195, or let's say 19. 19, 195, 254, 246. And our address is 55, 214. Actually, I think I'll probably just cut it back there because I'm running up on 10 minutes. And this stuff is kind of weird. So, the thing about these addresses, is that other than 8888, it's not easy to remember. Oh, 8888 is Google's DNS server. What DNS is the system we use so that you don't have to remember that Google is at, an address like this. You can just say google.com and it will look up the address and send something to this, because these addresses are what are used. But for humans, we use the domain names in the domain name system. So I'm going to cut this and go on for domain name system in the next video.